Hello students. So today I am doing class for class 12 science. The topic is first order derivative. So in the last online class also we were doing the same topic, that is first order derivative. So this is your continuation class. So in the last class also we were doing some problems. We did up to problem number 4, number 5. So let's do from problem number 6 today. So number 4 is, that is from same exercise 3A. Each question carries 5 marks and it is page number 294. Okay. So find dy by dx when number 6 is y is equal to 2 tan inverse root over x minus a upon b minus x. Now in this case you have to find out dy by dx, but you cannot simplify this inverse circular function out here. Okay. You cannot do the trigonometric substitution here also, so that we can have tan inverse tan x form. So in this case you have to directly differentiate it by using 2 tan inverse x form. So which function will you take it as x? That is root under x minus a divided by b minus x. You should take it as x to differentiate it. Okay. So let us differentiate it directly to get the value for dy by dx. So write down differentiating both the sides. Differentiating both the sides with respect to x. So therefore dy by dx is equal to, so 2 is constant but 2 is with a variable tan inverse. So you should differentiate this tan inverse x form. So what is the differentiation of tan inverse x? It is 1 upon 1 plus x square. Now which function is taken as x? That is root over x minus a by b minus x was taken as x. So it is root over x minus a upon b minus x whole square into. So what is the differentiation of tan inverse x here? It is 1 upon 1 plus x square. Here you take x as root under x minus a divided by b minus x. Again you have to differentiate the term which is assumed as x. That is, this root over x minus a upon b minus x was assumed as x. Also you have to differentiate it. So it is just like your root over x form again. What is the differentiation of root over x? It is 1 upon 2 root over x minus a upon b minus x. Is that clear? Again, into which function was taken as x to differentiate it? That is x minus a upon b minus x. And again you have to differentiate the term which is assumed as x. That is d by dx of x minus a divided by b minus x. Again you have to differentiate x minus a divided by b minus x. Is that clear? So let us differentiate it. You can use u by v rule here, because both numerator and denominators are the variables here. Now keep the denominator as it is, that is b minus x into d by dx of, this is your x minus a, right? That is numerator is differentiated, keeping the denominator as it is. Then minus, again keep the numerator as it is, that is x minus a into d by dx of, this is your b minus x, right? So whole divided by denominator whole square. What is denominator whole square here? It is b minus x whole square. So here third bracket is closed. So we did the differentiation. So now you can cancel these 2 gets cancels, right? So let's simplify it further, or it is dy by dx is equal to 1 upon 1 plus, what is square root whole square? Square root will be removed, isn't it? So it is x minus a upon b minus x, right? Into, now this is square root in the denominator. So you can write square root in both the numerator as well as in the denominator. Here down here. Now this root over b minus x goes up in the numerator. That is root over b minus x divided by root over x minus a. Is that clear? Then within the bracket we have here b minus x into, what is d by dx of x minus a? d by dx of x is 1 minus d by dx of a is 0 because a is constant. So into this is only 1. Then minus x minus a into, again what is d by dx of b minus x? For b, d by dx of b is 0, that is constant quantity, into what is d by dx of minus x? That is minus 1. This whole divided by b minus x whole square. So here third bracket is closed, right? So now again let us simplify it once again. Or dy by dx, or this is your dy by dx is equal to 1 upon, what's the LCM in the denominator? It is b minus x. Now here what will be there? It is b minus x, then plus x plus and minus a, right? Into, it is root over b minus x divided by root over x minus a. Keep it same now. So within third bracket, now simplify the numerator. It is b minus x, then minus and minus plus x minus a whole divided by, in the denominator, it is b minus x whole square. Is that clear now? So now let us simplify it further. So here xx gets cancel it. Now here also you can cancel this b minus x and square gets cancels. Here also minus x plus x gets cancels, or it is dy by dx is equal to 1 upon, this is your b minus a into root over, this is b minus x divided by root over x minus a, and within third bracket what is there? It is b minus a divided by, it is b minus x. Is that clear? So you can cancel here, this b minus a gets cancels, and this root over b minus x and b minus x will be cancelled. It goes root over b minus x, right? Now next, what will you do? You can simplify it further. Dy by dx is equal to, now it is 1 into 1 is 1, again 1. 1 divided by, in the denominator you can write down this square root, x minus a into within square root, it is b minus x. Or you may write it as, or dy by dx. So dy by dx is equal to, this is 1 upon, it is root over, what can you write? It is x minus a into what? B minus x. It is just like your root over a into root over b is root over ab. So likewise, root over x minus a into root over b minus x, you can write it within a square root. So within a square root, we have here x minus a into b minus x. So that is your answer. So this is the value for dy by dx. Is that understood? So this question is very, very important. So you can copy it. So we'll do the next question now. So now we'll do the next question, that is for number 7. Here also you have to find out dy by dx when the given function is y is equal to cos inverse a plus b cos x divided by b plus a cos x. So in this case also you cannot simplify this inverse circular function. You cannot convert it into the form of cos inverse cos theta, which is equal to theta. So here also you have to directly differentiate it by taking it as cos inverse x. All this fraction within bracket, you should take it as x, right? So let us differentiate it directly. So differentiating both the sides, with respect to x. So therefore this is your dy by dx is equal to, now it is just like a cos inverse x, that is the expression within bracket is taken as x. So it is cos inverse x. So what is the differentiation of cos inverse x? It is minus 1 upon root over 1 minus x whole square. But what is x in this case? So a plus b cos x divided by b plus a cos x. This is your whole square, right? Into. Again, you have to differentiate the term which is assumed as x, isn't it? Which function was taken as x? A plus b cos x divided by b plus a cos x was taken as x. You have to differentiate the function which is assumed as x. That means you have to differentiate a plus b cos x divided by b plus a cos x again, right? So within third bracket, let us write down the differentiation of this fraction. Okay, so you know u by v rule. So you have to keep the denominator as it is, that is b plus a cos x is kept as it is into. Now differentiate the numerator. What is the differentiation of a? It is 0. What is the differentiation of plus b cos x? It is minus b sin x. You know that, isn't it? Minus b sin x, right? Now comes minus sign because this is u by v rule. Okay. Now you have to keep the numerator as it is, that is a plus b cos x. So here numerator is a plus b cos x, that is kept as it is, into. Now differentiate the denominator again. What is the differentiation of the denominator? For b it is 0, but for plus a cos x, what is it? Minus a sin x into minus a sin x. This whole divided by, what will you write? Denominator whole square. So it is b plus a cos x whole square. So I think you have understood it. Okay, so this is the differentiation of this function, right? So let us simplify it, or it is dy by dx is equal to minus 1 upon within the square root 1 minus. Now this square is for both numerator as well as denominator, right? So this is a plus b cos x whole square divided by b plus a cos x whole square into. Now within third bracket, let us simplify it. So it is b into minus b sin x is minus b square sin x plus or minus minus ab sin x cos x, right? Next, now minus a into minus a sin x, that is plus, this is plus a square sin x, then minus into minus plus, let us write it here in the next step, minus into minus plus ab sin x cos x. AB sin x cos x. This whole divided by, what is the denominator out here? It is b plus a cos x whole square. So here third bracket is closed. Okay. Now here we can cancel this. Minus ab sin x cos x plus ab sin x cos x gets cancels. You can cancel them. Okay. Now let's simplify it, or dy by dx is equal to minus 1 upon within square root. What's the LCM? Here the LCM is in the denominator b plus a cos x whole square is the LCM. So that is, what is there in the denominator now? What is the denominator here? So it will be 1 into b plus a cos x whole square, b plus a cos x whole square, then minus what do we get? A plus b cos x whole square, a plus b cos x whole square. So in the denominator, here the LCM is b plus a cos x whole square. So above this expression, what will be there? B plus a cos x whole square. B plus a cos x whole square into 1 is b plus a cos x whole square minus a plus b cos x whole square, right? So into, now it is minus b square sin x plus a square sin x. What is common there? Sin x is common, isn't it? Let us write positive sin x. So within bracket you write a square minus b square. So it is a square minus b square. This whole divided by what? That is b plus a cos x whole square. B plus a cos x whole square. Is that clear now? So now let us simplify it further. Now, or dy by dx is equal to, now in this denominator, again in the denominator there is b plus a cos x whole square. You very simplify, it goes up in the numerator. And what is square root of b plus a cos x whole square? That is only b plus a cos x. So let us write it in the numerator, b plus a cos x. Because of the square root, this square will be cancelled. Because of this square root, this square will be cancelled. Divided by, within square root, you can simplify it further, a plus b whole square. What is the formula now? This is a plus b whole square, a square plus 2ab plus b whole square. What is it? It is b whole square, b square plus what is twice ab? Twice ab cos x plus a square cos square x, right? Then next, a plus b whole square again, a square plus 2ab plus b square, but there is minus sign here, you have to change the sign. Minus a square minus 2ab cos x, then minus b square, it is cos square x. Is that clear now? So it is done, right? So in the numerator, you can keep the numerator as it is, sin x into a square minus b square divided by denominator also you can keep it as it is, that is b plus a cos x. This is your whole square. Is that clear? So b plus a cos x and this square will be cancelled, right? So next one, again you can simplify it further within square root. Here you can cancel 2ab cos x. 2ab cos x will be cancelled, or it is dy by dx is equal to 1 upon. Now within square root, okay? So within square root, what will you write now? So within square root there is b square minus a square. So it is b square minus a square. So I have left here minus sign. There is minus sign here, write on minus sign. So this is minus 1, right? So b square minus a square is kept within bracket, okay? Again you take minus common here. Minus cos square x is taken common, right? From these two terms, minus cos square x is taken common. So within bracket, what do we get? It is b square minus a square, right? So into sin x into, here also you take minus common because minus into minus will be plus. That's why you should take minus common here. So it is b square minus a square. This whole divided by in the denominator, what do we write? It is only b plus a cos x. Is that clear to all of you now? So I think you have understood it. Or dy by dx, or now dy by dx is equal to, this is minus into minus is plus, right? So it is b square minus a square into what? That is sin x. This whole divided by within square root. What is common out here? It is b square minus a square, right? So it is b square minus a square is taken common. So within bracket, what do we get? It is 1 minus cos square. And again there is another expression, that is outside square root. There is another expression, that is it is b plus a cos x. So is that understood now? So we are getting dy by dx in the simplified form. Again you can simplify it further, right? So let us simplify it further now. You will get the simplified answer here. So dy by dx is equal to, so this is minus into minus is plus sign. So usually we don't write plus sign, okay? So it is b square minus a square into what? Into sin x is there, okay? So divided by, in the denominator within square root there is b square minus a square into, again, what is 1 minus cos square x? What is 1 minus cos square x? It is sin square x into, now within bracket there is a factor b plus a cos x. Is it understood now? So let us simplify further now. Or dy by dx is equal to b square minus a square into sin x divided by, in the denominator, so within square root there will be only this expression, that is root over b square minus a square into, what is square root of sin square x? That is only sin x, isn't it? What is square root of sin square x? That is only sin x into b plus a cos x. Is that clear now? So next step. So now in the next step, you can cancel this sin x, okay? Or dy by dx is equal to, it is b square minus a square divided by root over b square minus a square within bracket b plus a cos x. Clear? So next, again you can cancel this root over b square minus a square divided by root over b square minus a square 1. Again you can cancel this b square minus a square by root over b square minus a square. That is, it is root over b square minus a square. Clear? So what is the value for dy by dx now? So dy by dx is equal to, within square root it is b square minus a square divided by, in the denominator we have b plus a cos x. So this is the final answer. Understood? So we'll do the next problem now. So now we'll do the next question, that is for number 8. Find dy by dx when y is equal to tan inverse within bracket within square root a minus b upon a plus b into tan x by 2. So here also this inverse circular function cannot be simplified further. So here also you have to differentiate both the sides directly by taking it as tan inverse x. That is, the expression within bracket is root under a minus b upon a plus b into tan x by 2. You should take it as x to differentiate it. Okay. So let us differentiate it directly again. So differentiating both the sides. Differentiating both the sides with respect to x. So therefore it is dy by dx is equal to, now differentiate it. You should take it as tan inverse x. Okay, what is the differentiation of tan inverse x? It is 1 upon 1 plus x square. But which function is taken as x? It is within square root a minus b upon a plus b, tan x by 2 is taken as x. So the formula is 1 upon 1 plus, what is x? Whole square root over a minus b divided by a plus b into tan x by 2 whole square. That is your 1 upon 1 plus x square. But this is not the only differentiation. You have to differentiate the function which is assumed as x. In this case, which function is assumed as x? Root under a minus b upon a plus b into tan x by 2 is assumed as x. You have to differentiate that term. That is, again you have to differentiate root over a minus b by a plus b into tan x by 2. Right? But in this case, this root over a minus b upon a plus b is free from x. So this is a constant quantity. Now differentiate tan x by 2. What is the differentiation of tan x by 2? It is sec square x by 2 into half, right? So how is this tan x by 2 differentiated? You should take it as a tan x. What is the differentiation of tan x? Sec square x. But here it is sec square x by 2. Now in this case also x by 2 was taken as x. Again you have to differentiate that term x by 2 with respect to x. That is half into d by dx of x. What is d by dx of x? That is 1. So it is only half. Is that clear? Now let us simplify it. Okay. So now, or dy by dx is equal to 1 upon 1 plus. So within square root a minus b upon a plus b whole square, what is it? It is a minus b upon a plus b. Okay. Then tan square x by 2. Then you write tan square x by 2 into. Now this square root is for both numerator as well as denominator. You can write down the square root in the numerator, root over a minus b divided by root over a plus b into sec square x by 2 can be written as 1 by cos square x by 2. Let us write it as 1 upon cos square x by 2 into half. Okay. Now again you have to simplify it further, right? Now you have to simplify it, or it is dy by dx is equal to 1 upon 1 plus a minus b upon a plus b into. What is the formula for tan square x by 2? It is sin square x by 2 divided by cos square x by 2. Okay, into, then within root a minus b upon within root it is a plus b into 1 upon cos square x by 2, 1 upon cos square x by 2 into this is half. Okay. So next, or dy by dx, or dy by dx is equal to 1 upon, what's the LCM here now? So what's the LCM? A plus b into cos square x by 2 is the LCM. Okay. So what will be the expression above this denominator? What will be the expression here above this denominator? You have to multiply this one by LCM a plus b cos square x by 2, right? So it is a plus b into cos square x by 2 plus next this is a minus b into sin square x by 2. You know how to get the LCM and simplify, right? So into all of the terms, keep them as they are, right? Root over a minus b divided by root over a plus b into, that is 1 upon, this is your cos square x by 2 into half. Is that clear? Now here, can you cancel any term here? You can cancel this. Cos square x by 2 gets cancels. Now this a plus b goes up in the numerator, or dy by dx is equal to, now a plus b goes up in the numerator divided by, in the denominator you can simplify it further, right? A cos square x by 2, a cos square x by 2 plus b cos square x by 2, right? Then you can write plus a sin square x by 2 plus a sin square x by 2, then minus b sin square x by 2, minus b sin square x by 2. Okay. Then next, root over a minus b upon root over a plus b into, this is half. Is it clear to all of you now? Now let us simplify it further. Now this root over a plus b and this a plus b will be cancelled. That means it is root over a plus b in the numerator. But that is we are cancelling this a plus b by root over a plus b. That means root over a plus b into root over a plus b is a plus b. That means if you cancel this a plus b, you should write here root over a plus b. If you cancel a plus b by root over a plus b, you will get root over a plus b. Okay. So now in the next step, or dy by dx is equal to, now here root over a plus b into root over a minus b. You can simplify it further, isn't it? That is root over a plus b into a minus b. So it will be root over a square minus b square divided by this root over a plus b, root over a minus b, they are multiplied. that is root under a plus b into a minus b, which is equal to root under a square minus b square. Now here from these two terms, a is common. So within bracket, what do we have? Cos square x by 2 plus sin square x by 2. Alright. Then from these two terms, what is common? Plus b is common. So within bracket, what do we get? Right now, cos square x by 2. Cos square x by 2 minus it is sin square x by 2. Clear? So into half is there. Into 1 upon 2. Right? So or it is dy by dx is equal to root over a square minus b square divided by, now this is, what is cos square x by cos square x by 2 plus sin square x by 2? It is 1 a plus b into, what is that? What is cos square x by 2 minus sin square x by 2? You know, from submultiple angle there is a formula for that. That is cos x, isn't it? Cos x is equal to cos square x by 2 minus sin square x by 2. So write down b cos x. So into, it is 1 upon 2. Is it clear to all of you? So now let us write down the final answer now. What is the final answer? Or dy by dx is equal to, it is root over a square minus b square divided by 2 into, within bracket, it is a plus b cos x. So this is the final answer. Is that clear? This question is very, very important. So you can copy it. We'll do the next question now. So now we are doing the next question. So this question is very, very important. That is 4 number 9. Find dy by dx when y is equal to sine, within third bracket, 2 tan inverse root over 1 minus x divided by 1 plus x. Third bracket is closed. But this inverse circular function can be simplified further. You can do the trigonometric substitution here. What should you do? Substitute for x. What should you substitute for x so that we can have it in the form tan inverse tan theta? What should be the trigonometric substitution for x so that we can have tan inverse tan theta form? So you can put x is equal to cos theta, because if we put x is equal to cos theta, we have 1 minus cos theta, isn't it? So 1 minus cos theta is, you know that this is the formula, 2 sin square theta by 2, right? Again 1 plus cos theta. If you put x is equal to cos theta here, 1 plus cos theta, right? What is the formula for 1 plus cos theta? It is 2 cos square theta by 2. Is that clear now? So let us put x is equal to cos theta. Let x is equal to cos theta, then get the value for theta. What is theta? Is equal to cos inverse x. We may or may not use the value for theta is equal to cos inverse x, or we may use x is equal to cos theta also. Okay, so let us check it. Now let us simplify it now. So therefore y is equal to sine, within third bracket, this is your 2 tan inverse, within square root 1 minus, what is x? It is cos theta, right? Divided by 1 plus cos theta. So we have put the value for x, which is equal to cos theta, right? Or y is equal to, this is your sine inverse within third bracket, 2 tan inverse within square root. What is 1 minus cos theta formula? It is 2 sin square theta by 2, right? It is 2 sin square theta by 2 divided by, what is 1 plus cos theta? It is 2 cos square theta by 2. We have put this formula out here. Okay? 1 minus cos theta is 2 sin square theta by 2. What is 1 plus cos theta? It is 2 cos square theta by 2. So here you can cancel these 2 gets cancels. You can cancel them. Next, or y is equal to, now it is sine inverse, or not sine inverse, sorry. This is not sine inverse. It was only sine, isn't it? it was only sine. Sine within third bracket 2 tan inverse. Now within bracket, it's only sine, okay, not sine inverse, because in the question it is given only sine is there, right? So now sine within third bracket 2 tan inverse. Now what is sine square by cos square? Tan square. What is square root of tan square? There is only tan, so it is tan theta by 2. So this is your tan theta by 2. That is, third bracket is closed. Or y is equal to, this is your sine. Now within third bracket, 2 into, what is that? Tan inverse tan theta by 2? It is theta by 2, right? So it is theta by 2. Here 2 gets cancels. Or y is equal to, this is your sine theta. Okay? So I think I've understood it. So this is the simplified form, that is sine theta. But don't put theta is equal to cos inverse x. Okay? Don't put theta is equal to cos inverse x. This is not your simplified value of y. Okay? But you know cos theta is equal to x. So if you can express this sine theta into cos theta, then you can put cos theta is equal to x easily out here. Isn't it? So what is the formula for sine theta now? Or y is equal to, it is root over 1 minus cos square theta. You know the formula, isn't it? So sine theta is root over 1 minus cos square theta. Or y is equal to, this is your root over 1 minus, what is cos square theta? It is x square. So y is equal to root under 1 minus x square. So this is the simplified expression of this given function. That is y is equal to root under 1 minus x square. Now it will be easier for you to differentiate it, isn't it? So write down differentiating both the sides with respect to x. So write down differentiating both the sides, with respect to x. So therefore it is dy by dx is equal to, what is it? What is the differentiation of root over? It is just like your root over x. 1 minus x square is taken as x. What is the differentiation of root over x? It is 1 by 2 root over 1 minus x square. Okay? 1 by 2 root over x means 1 by 2 root over 1 minus x square. Again differentiate the term which is assumed as x. Which function was taken as x here? 1 minus x square. Again you have to differentiate 1 minus x square. What is it? For 1 it is 0. You don't have to write it. For minus x square, what is it? You have to write minus. But what is the differentiation of x square? It is 2x. Right? So here 2 gets cancels. So what is the value for dy by dx now? So dy by dx is equal to minus x upon root over 1 minus x square. So this is the final answer. Okay, you have understood? So this question is very, very important. This question is from 4 number 9, right? So you can revise it at home. So we'll do the next question now. You can copy it. So now, we'll do the next question, that is for number 10. Find dy by dx when number 10 is y is equal to sine inverse 1 upon root over 1 plus x square plus tan inverse within bracket root over 1 plus x square minus 1 whole divided by x. Right? So now in this case, you cannot differentiate it directly. It will be complicated. So in this case, you can do the trigonometric substitution. Okay, so let's do the trigonometric substitution for x in this case. So we can have it in the form sine inverse sine theta form. This is tan inverse tan theta form, right? So what should you put for x? So I told you that whenever you have 1 plus x square, you can put x is equal to tan theta or it may be cot theta. Let us check it. Okay, so if you put here tan theta, this will be root over 1 plus tan square theta. Root over 1 plus tan square theta is what? What is root over 1 plus tan square theta? It is what? Root over 1 plus tan square theta is sec theta. What is 1 by sec theta? Cos theta. Cos theta can be easily converted into sin theta by writing sine of pi by 2 minus theta. Is that clear? So here also you can put x is equal to tan theta. Root over 1 plus tan square theta is sec theta, isn't it? So let us put x is equal to tan theta. So let x is equal to tan theta. Now get the value of theta in this case. So theta is equal to tan inverse x. So therefore y is equal to sine inverse within bracket 1 upon root over 1 plus tan square theta, right? Plus tan inverse within bracket root over, this is 1 plus tan square theta minus 1 divided by, what is x out here? It is tan theta. We are just putting the value of x that we have assumed. That is, x was assumed as tan theta. So it is sine inverse 1 over root over 1 plus tan square theta plus tan inverse within bracket root under 1 plus tan square theta minus 1 whole divided by tan theta, right? So let us simplify it. Or y is equal to sine inverse within bracket. You know this formula. 1 upon, what is root over 1 plus tan square theta? It is sec theta plus tan inverse within bracket. What is root under 1 plus tan square theta? It is sec theta. It is sec theta minus 1 divided by, this is your, what? It is tan theta. Is that clear? Now let us simplify it again. You can simplify it further, right? Or y is equal to, this is sine inverse, what is 1 by sec theta? It is cos theta, okay? Plus tan inverse, you can simplify it further. Sec theta, you should write it in terms of cos, it is 1 by cos theta minus 1 divided by, what is tan theta in terms of sine and cos? It is, this is your sine theta divided by cos theta, okay? Now again simplify it, y is equal to sine inverse. So you should convert this cos theta into sine theta. But you cannot write here cos theta is root over 1 minus sine square theta. Because sine inverse within bracket root over 1 minus sine square theta will not be simplified further. But you should write it in terms of sine. But you should write the formula sine of, this is your pi by 2 minus theta. Is that clear? That is cos theta, instead of cos theta, what do we write? Sine of pi by 2 minus theta plus tan inverse within bracket. What's the LCM in the numerator? In the numerator, cos theta is the LCM. So in the numerator, what will be there? It is 1 minus cos theta. So this fraction is in the numerator. So this is the fraction, this cos theta is in the denominator, but it is in the numerator. And this 1 minus cos theta is in the numerator, divided by, it is sine theta by cos theta. Is that clear? So in the numerator, cos theta is the LCM. So it will be 1 minus cos theta divided by sine theta by cos theta, right? So now here you can cancel this cos theta. Or y is equal to, what is sine inverse sine of pi by 2 minus theta? It is pi by 2 minus theta, right? So it is pi by 2 minus theta, okay? Plus tan inverse within bracket 1 minus cos theta divided by sine theta. So we have simplified the first term, that is sine inverse sine of pi by 2 minus theta is pi by 2 minus theta. Now we have to simplify the second term, that is tan inverse within bracket 1 minus cos theta by sine theta. So or y is equal to, this is pi by 2 minus theta plus tan inverse within bracket. What is 1 minus cos theta? It is 2 sine squared theta by 2 divided by. Now what is the formula for sine theta? It is 2 sine theta by 2 cos theta by 2. So you know the formula of 1 minus cos theta from submultiple angle, which is 2 sine square theta by 2. Okay. Now what is the formula for sine theta? It is 2 sine theta by 2 cos theta by 2. So here you can cancel 2 and sine theta by 2 square gets cancels, right? So next, or y is equal to, it is pi by 2 minus theta, right? Plus tan inverse within bracket. This is only sine theta by 2 by cos theta by 2, which is equal to tan theta by 2, or y is equal to pi by 2 minus theta plus, again what is tan inverse tan theta by 2? It is theta by 2, right? So let us simplify further now, or y is equal to pi by 2. Now let us simplify it. Minus 2 theta plus theta, that is minus theta by 2. Is that clear? Minus theta plus theta by 2 can be simplified further. Here 2 is the LCM. 2 into minus theta is minus 2 theta plus theta, that is minus theta by 2. So let us put the value for theta here. Or y is equal to, this is pi by 2 minus, you can write half, and we had assumed x is equal to tan theta, isn't it? We had assumed x is equal to tan theta, but what is the value for theta? It is tan inverse x. So theta is equal to tan inverse x here. Okay, now we can easily differentiate this function with respect to x. That means you can get dy by dx. So differentiating both the sides. So differentiating both the sides with respect to x. Therefore dy by dx is equal to, what is d by dx of pi by 2? It is constant quantity, so it is 0. Minus half into, what is the differentiation of tan inverse x? It is 1 upon 1 plus x square. So the final answer is, what is the final answer? Therefore dy by dx is equal to minus sign. So it is 1 ones are 1. 1 divided by 2 into 1 plus x square. So this is the final answer. So I think you have understood it. So you can copy it. We'll do the next question now. So now we will do the next question, that is for number 11. Find dy by dx when the question given here is x to the power sine y plus y to the power sine x is equal to 1. So you have to get the value for dy by dx for this given equation, right? So this is very important question. You can mark it, right? So now how do you do it? This base is the variable, power sine y is also the variable. You cannot differentiate it directly. Here also y to the power sine x is given. Y is the base variable, sine x power is also the variable. You cannot take a log on both the sides here because there is plus sign out here. Okay, if there is plus sign here, you cannot take log on both the sides because log of a plus b cannot be simplified further. So in this case you can use UV method. Let us assume this first term as u and the second term as v. So let us write, instead of x to the power sine y, let us write u plus, and let us assume y to the power sine x as v, which is equal to 1. So where u is equal to x to the power sine y and v is equal to y to the power sine x, right? So both u and v are the functions of x and y. So these are also the variables. So you have to find out, you have to differentiate both the sides with respect to x and get the value for dy by dx. So let us write here differentiating both the sides. Differentiating both the sides with respect to x, right? So this is your du by dx plus dv by dx is equal to, what is d by dx of 1? That 1 is a constant term, that is 0. Let us mark it number 1, right? So let us find out the individual values of du by dx and dv by dx. Okay, so let u is equal to, what is u is equal to? X to the power sine y, right? Let u is equal to x to the power sine y. Okay, but you cannot differentiate it directly here because x is the variable, power sine y is also the variable. So you should take sine y to the front of x. So you have to take log on both the sides. So here the method is taking log on both the sides. taking log on both the sides. What do we get? So log u is equal to log x to the power sine y, okay? Or log u is equal to now, now power becomes the coefficient because of that log, isn't it? Sine y log x. So it is sine y log x. Is that clear to all of you? Now you have to get the value for du by dx, okay? So differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So let us find out this differentiation, okay? Or what is the differentiation of log u with respect to x? First of all, it is 1 upon u into du by dx, which is equal to, now on the right hand side both are the variables here, you can use UV rule, product rule, isn't it? So sine y is kept as it is, you know product rule, log x is 1 by x plus, now log x is kept as it is, that is log x into, what is the differentiation of sine y with respect to x? First of all, it is cos y, then what do we write? It is dy by dx. So I think you have understood it, okay? Now we do cross multiplication. So du by dx is equal to u, and within bracket, what do we write? Sine y into 1 upon x plus, what is the second term here? It is log x into cos y into dy by dx. Your bracket is closed. So you have understood? Now we have to put the value for u on the right hand side. What is u here? Here u is equal to x to the power, u is equal to x to the power sine y, okay? So or it is du by dx is equal to, what is the value for u here? It is x to the power sine y, and within bracket it is sine y upon x plus log x into cos y into it is dy by dx. So this is the value for du by dx, okay? Now similarly you can find out the value for dv by dx. We had assumed v is equal to y to the power sine x, okay? So again let v is equal to what? What is v is equal to? Y to the power sine x. It is y to the power sine x, okay? So here also you cannot differentiate both the sides with respect to x directly, because on the right hand side this y is the base, this is the variable, power sine x, this is also the variable. If base and powers are both variables, you cannot differentiate it directly. You have to take log on both the sides, okay? So taking log on both the sides, taking log on both the sides, taking log on both the sides, what do we get? It is log v is equal to log y to the power sine x, okay? Now because of that log on the right hand side, that power sine x becomes the coefficient. So or log v is equal to sine x into log y. Sine x into what? Log y, right? Now again, you can differentiate both the sides with respect to x now, isn't it? Because both left hand side and right hand side are simplified. Now we can differentiate both the sides with respect to x. So write down differentiating both the sides with respect to x. So what is the differentiation of log v with respect to x? First of all, it is 1 by v into dv by dx, which is equal to, on the right hand side also you can use UV rule there, isn't it? Sin x is kept as it is into, what is the differentiation of log y with respect to x? It is 1 by y into dy by dx plus now log y is kept as it is. Now we have to differentiate sin x. What is the differentiation of sin x? It is cos x, okay? Now get the value for dv by dx. So dv by dx is equal to, cross multiply by v here, v is equal to cross multiply by v. So dv by dx is equal to v within bracket sin x upon y into dy by dx plus it is log y cos x. So here bracket is closed. Okay. Now next, what will you do? Put the value for v, or dv by dx is equal to, what is the value for v out here? V was y to the power sin x. Okay. Put the value for v, y to the power sin x within bracket sin x upon y into dy by dx plus it is log y into what? It is cos x. Is that clear to all of you? So now what will you do now in the next step? Since you have to find out the value for dy by dx, so you can put the value for du by dx and dv by dx in equation number 1. We had marked as equation number 1, isn't it, in the beginning? That is du by dx plus dv by dx is equal to 0. So from 1 we have, therefore du by dx plus dv by dx is equal to what? It is 0. So let us put the values of du by dx and dv by dx. Okay. So now, or what was the value for du by dx? It is x to the power. Let us write here this one. That one is the value for du by dx, isn't it? So du by dx. This is the value for du by dx. That is x to the power sin y. And within bracket, what do we have? Sin y upon x plus what? Log x cos y into dy by dx. Bracket closed. Okay, that is the value for du by dx. Then plus, let us write it here because there is no space out there. Okay, so dv by dx. What is the value for dv by dx? It is y to the power sin x. It is y to the power sin x. Then within bracket, what do we have? It is sin x divided by y into dy by dx, right? Sin x by y into dy by dx. Then plus log y cos x. Plus it is log y cos x, which is equal to what? It is 0. So is that understood now? So let us simplify it further. Let us simplify it further now. Or now we have to simplify it. Okay. So multiply this expression by x to the power sin y. So it is x to the power sin y into sin y upon x, right? Plus x to the power sin y into log x into cos y into, this is your dy by dx. Is that clear? Next, plus, now multiply by y to the power sin x here. It is y to the power sin x into sin x by y into dy by dx plus, next, what will you write here? It is y to the power sin x into log y cos x. Log y cos x, which is equal to 0. So I think you have understood it. Okay. Now we have to get the value for dy by dx now. So now in this case, you have to keep the terms containing dy by dx on the left hand side, and all of the terms which are free from dy by dx, take it to the right hand side. Okay. So or on the left hand side, second term and third term contain dy by dx. So what is common? Dy by dx is taken common. So within bracket, what do we have? X to the power sin y, x to the power sin y log x, then cos y, plus next y to the power sin x, y to the power sin x into sin x by y to the power sin x into sin x by y, and dy by dx is taken common, isn't it? So this is the expression within bracket. So from these two terms we have taken dy by dx as common. So within bracket, x to the power sin y into log x cos y plus y to the power sin x into sin x by y. Okay, and all other terms which are free from dy by dx, take them to the right hand side. Okay, so it will be minus sign, and within bracket what do we get? What do we get within bracket? Minus sign. When these terms goes to the right hand side, they become minus, isn't it? And minus sign is taken common. So what do we get? X to the power sin y into sin y upon x, then plus it is y to the power sin x, then log y cos x, then it is log y cos x, bracket is closed. So I think you have understood it. Now you can easily get the value for dy by dx. Okay, let's take the LCM on the left hand side, or dy by dx. What's the LCM here? This is y, so it is y into x to the power sin y, it is log x cos y, plus y to the power sin x into sin x, bracket closed, which is equal to minus sign is there, minus within bracket. What's the LCM? The LCM is x, right? So numerator becomes x to the power sin y into sin y, plus what do we write there? X into y to the power sin x into log y cos x. Is that clear to all of you? Just we are taking the LCM and simplifying the numerator. So what is the value for dy by dx? Or dy by dx is equal to, now cross multiply by y here. So it is minus y within bracket. What do we get? X to the power sin y into sin y plus x y to the power sin x into log y cos x, bracket closed. This whole divided by, now you can cross multiply by this expression. So x into what? X into within bracket y, x to the power sin y into log x cos y, plus y to the power sin x, y to the power sin x into sin x, Is that clear now? So this is the final answer. So this is your final answer. Understood? So this question is very, very important. You may get this type of question in your HS examination. Okay? So we'll do the next question now. So now we are doing the next question, that is question number 5. If y is equal to within the bracket tan x whole to the power tan x, again whole to the power tan x is there. Find dy by dx at x is equal to pi by 4. So here given is y is equal to tan x whole to the power tan x whole to the power tan x. So these are in the powers. It is tan x whole to the power tan x whole to the power tan x. So these are in the powers. So these two powers must be multiplied. Why is it multiplied? Why is it not added? Let us, I'll give you some example. That is x square whole cube. Is it x to the power 5 or x to the power 6? So let us simplify it. X square whole cube means x square is multiplied how many times? 3 times, isn't it? That is x square into x square into x square, which is equal to x to the power. Now powers will be added, isn't it? X square into x square into x square. If you multiply all these x square, the powers will be added. What do we get? 2 plus 2 plus 2, that is 6. That means x square, if there is x square whole cube, these two powers must be multiplied. That is 2 3s are 6. Similarly here also, this tan x and tan x should be multiplied. Is that clear now? So we cannot write 2 tan x here because these powers cannot be added. Likewise, here it is x square whole cube. 2 plus 2, there is no 5 out here. It is x to the power 6. How do you get this x to the power 6? These 2 and 3 are multiplied. So likewise, you should multiply tan x by tan x, which is equal to tan square x. Okay? So or y is equal to, this is your tan x whole to the power tan x into tan x is tan square x. Okay. Now here also the base is the variable, power is also the variable. Both are the variables here, so you cannot differentiate it directly. You have to take log on both the sides. So taking log on both the sides. Taking log on both the sides. So what do we get? This is log y is equal to log of, this is your tan x whole to the power tan square x. Okay. Now we can simplify the right hand side. This tan square x powers becomes the coefficient because of that log. So or it is log y is equal to, this is your tan square x into log of tan x. Okay. Now we can differentiate both the sides with respect to x now. So write down differentiating both the sides with respect to x. Differentiating both the sides with respect to x. Okay. Or what is the differentiation of log y with respect to x? That is 1 by y. 1 by y into dy by dx is equal to, now which rule is applied here? UV rule, right? So tan square x is kept as it is. Tan square x into, now differentiate log of tan x, it will be 1 by tan x, isn't it? It is just like your log x form. Log x differentiation is 1 by x, but here it is 1 by tan x. This tan x was assumed as x. Again you have to differentiate tan x with respect to x, that is sec square x. So this is your sec square x plus. Now again you have to differentiate tan square x, keeping log tan x same. So what is the differentiation of tan square x now? It is just like your tan x whole square. That is your x square form. What is the differentiation of x square? It is 2x. Which function is taken as x? Tan x is taken as x there. Okay. So it is, first of all, it is 2 tan x into 2 tan x. Again you have to differentiate the term which is assumed as x. That is tan x was assumed as x. So what is the differentiation of tan x? That is sec square x. That is your sec square x into log of tan x is kept as it is. That is log of tan x remains same. Log of tan x remains same, right? So here tan x and square will be cancelled, or 1 upon y into dy by dx is equal to, now it is tan x sec square x, tan x sec square x plus what is the second term out here? It is 2 tan x sec square x into log of tan x. Is that clear now? So now we can do cross multiply. Now we can cross multiply here, or dy by dx is equal to y. So dy by dx is equal to y, and within third bracket, what do we get? Tan x sec square x, tan x sec square x plus what? 2 tan x sec square x into what? Into log of tan x into log of tan x. So we got this expression. Okay. Now we can put the value for y also. What was the value for y? It is tan x whole to the power, tan x into tan x is, this is your tan square x into, now from these two terms again you can take common there. What is common there? It is tan x into sec square x is taken common, so within third bracket. So what do we get within third bracket? Yes, what do we get? Tan x sec square x is common, so it is 1 plus 2 log of tan x. 1 plus 2 log of tan x. So this is the value for dy by dx. But in this particular problem, we have to find out the value for dy by dx at x is equal to pi by 4. Now you can put x is equal to pi by 4 here. Okay. So putting x is equal to pi by 4. So therefore dy by dx is equal to, this is your tan pi by 4 whole to the power 10 square pi by 4. This is your 10 pi by 4 sec square pi by 4 within third bracket. 1 plus 2 log of within bracket, it is 10 pi by 4. So third bracket is closed. So is that clear to all of you? So now we can simplify it further now. You can simplify it, or dy by dx, these are all standard angles. You know the value of this standard angles. 10 pi by 4 is 1, and this is your 1 square. What is 10 pi by 4? 10 pi by 4 is also 1 into what is sec pi by 4? It is root 2 whole square, right? And within third bracket, 1 plus 2 log of within bracket, it is 1, because 10 pi by 4 is always 1, right? So next, what should you do? Or dy by dx is equal to 1 square is 1, 1 whole to the power 1 is 1, 1 ones are 1, and root 2 whole square is 2. And within third bracket, 1 plus 2 into log 1 is 0, you know that. What is log 1 here? 0, right? So simplify it, what do we get? Or dy by dx is equal to 2 within bracket 1 plus 2 zeros are 0. Or what is the value for dy by dx now? Dy by dx is also, what is the value for dy by dx? It is 2. So that is the answer. Okay. So this much is for today. So your homework is the revision. You revise all the problems that we did today. Okay. So this much is for today.